Hello, welcome to Cloud OnAir, the journey from big data to AI. I'm Cassie Kozarkov, a chief data scientist at Google Cloud, and I'm excited to introduce you to artificial intelligence. My goal today is to demystify the basics for you and show you that building intelligent applications is easier than most people think. So let's get started. Today, AI is everywhere. It powers self-driving cars. It lets us have fluent, real-time conversations with people who don't speak our language. It helps us organize images. For example, take a look at this satellite image. It's pretty hard to tell by eye what's cloud formation and what's snow cover. AI can help with that. It plays our favorite board games with us, and it wins. And it protects our infants from spoiled baby food by helping workers catch defective ingredients early. AI even helps improve the energy efficiency of the data centers required to power it. Exciting stuff. Hey, before we get any further, artificial intelligence, machine learning, what even are these things? Let's bust some jargon. What we think of as AI today is a special kind of machine learning, or ML for short. So let's first look at ML in general. Contrary to popular belief, ML is not a magical box of magic. Instead, it's all about labeling things automatically. In other words, it's one approach to making many small decisions with data. Decisions like, is this email spam? Yes or no? How much should I bid on this item? $1.05 or 88 cents? For each decision, the computer outputs a suggested answer automatically. Now, ML is not the only way to get this done. To see this, let's go back to basics. Making decisions involves taking in information, that is, data, and outputting an answer, or choice, by using a recipe that takes us from one to the other. For decades now, we've been using computers to help us make decisions faster. Everything from figuring out what number to write on our tax return to whether or not an image has a cat in it. Not all of it is machine learning, though. The difference between ML and traditional programming boils down to where that recipe came from. In traditional programming, the recipe is handcrafted by programmers and written as code, an explicit set of instructions for the computer. In machine learning, we let the data work for us, so we don't have to design instructions by hand anymore. Now the programmer's effort goes into producing examples that the machine can learn from, and then applying a machine learning algorithm to generate that recipe automatically. What we'll see later is that some tasks are so complicated that we couldn't possibly handcraft instructions for them, so the only way to get them done is to learn them from data. But first, let's talk about how a computer learns from data. We'll walk through an example task to see what the process for applying ML looks like. In this example, our mission is to build a system that can correctly decide whether I'm going to like a bottle of wine or not. A new bottle of wine that I have never tasted before. So let's try ML. Step 1. Define success. To get started, you're going to need a good imagination. What do you want machine learning to help you with? Don't worry yet about how the machine is going to learn the task. Rather, imagine what you want it to do. How would you know if the output it gives you is correct or not? What's the minimum performance you'd accept for the endeavor to even be worth your time? So what I'm saying is, start by focusing on the outputs. In the case of our wine example, I want my system to correctly say yes or no to a new bottle of wine. Then, I need to think about how good it needs to be. Let's see. I'm going to need it to have at least 80% accuracy for it to feel worth using. Otherwise, I won't bother with it. I'll just ask my friend for a recommendation instead. Great, that's step 1 done. Step 2, wrangle your data. Machine learning is not the kind of magic that makes something out of nothing. There has to be relevant data to learn from, so let's get some. How about using the age of the wine in years and a review score? Since this is a fictional example, I'll make up some data for us to learn from. Let's imagine that I tasted 100 bottles of wine, and I recorded the age, the review score, and whether I liked that bottle. The most important piece of data wrangling is what you will do next. Split your dataset into several pieces before you start using it. We'll see why in a little bit, but for now, let's only look at half of our data, 50 bottles of wine, and save the rest for something important we'll need later. Great, we're ready to do some learning. Let's look at the data that I dreamed up for you. Our inputs, we'll call them features to be a bit more formal, are on the X and Y axes respectively, and the correct answers are plotted as red Y's for yummy and blue ends for not so yummy. Machine learning will use patterns in the data to try to make a recipe that successfully separates the good ones from the bad ones. Why don't you try being my machine for a moment? Your job is to separate the red things from the blue things somehow. See any patterns you could use? How would you do it? If you imagine drawing a line and using it to make decisions, awesome! You've just invented a machine learning algorithm. But hang on. Where would you put that line? Are you sure you picked the best possible place? Where exactly to put your line is what a machine learning algorithm helps you with. That's what they're for. Which brings us to step 3. Train some models. In other words, make some recipes. In order to build solutions, you're going to need some machine learning algorithms. Feel free to just get some off the shelf and use them without worrying about how they work. You'll just pick one and run it. If you're wondering why you can get away with using tools whose math you haven't studied, here's a helpful analogy. Think of algorithms as kitchen appliances. If you're a machine learning researcher, your job is to build algorithms for others to use. You'd need to know exactly how a blender works in order to build a cutting-edge one. But if you're more interested in cooking something delicious, that is, if you're using ML to help your business, then you can use a blender or algorithm that someone else has already packaged up for you. You don't need to know how the wiring works in there. All you have to worry about is what ingredients or data you put in there, and you have to make sure to taste the smoothie that comes out, make sure it tastes good. If it doesn't taste how you want it to, try a different kitchen appliance or different ingredients until you get something delightful. We'll this in the next section. ML algorithms have all these cool names like support vector machines, random forests, neural networks, and so on. When you pick one, you're defining the shape that your recipe is allowed to have. For example, a support vector classifier is only allowed to use a single straight line to separate the good ones from the bad. A decision tree is allowed to use more than one line, but it can only use horizontal and vertical ones, no diagonals. A neural network can put a much more flexible boundary through your data, almost any shape you want. Later today, you'll learn a bunch more about neural networks, also known as deep learning. So let's focus on the 2 simpler algorithms for now. Suppose we decide to use a single line that's allowed to have any slope we like. That's us selecting the support vector classifier algorithm. When we run this algorithm, the machine uses the data to choose where to put the best line. Best in the sense of most effectively separating the good lines from the bad. Boom, there it is. Once it fits that line, what you get as output is what you've wanted all along, the recipe. In machine learning, we'll use the term model to mean recipe. That's all a model is, some instructions for the computer to use to convert data into answers next time. It's ready to use. A new data point, new bottle of wine comes in, and the model outputs red, delicious. We could have used a different algorithm that would give us a different form of recipe. Let's try a decision tree, which allows multiple vertical and horizontal lines. Run it. Here we go, and there's our recipe. What a beauty. Let's use it to make a decision about this same new bottle of wine. Blue for bad. Interesting. Notice how we got 2 different answers using 2 different models. Same bottle of wine, though. So, which model should we trust? The right way to pick solutions is not to blindly trust that machine learning is magically awesome. Blind trust is a terrible thing. After all, machine learning is just a way to turn patterns in your data into a recipe. Who knows if they're useful ones? Who knows if it'll work for your task? What do? We'll check it's trustworthy in step 4. Test your solution. You should never trust a machine learning model until it has successfully performed on new data. When you're studying for an exam, you should expect to be better at handling examples you've already practiced than brand new examples. To truly test your learning, it's important to try examples you've never seen before. That's the reason we split our data earlier. We kept some untouched examples for test driving our solutions. So how do we do our testing? We simply apply our recipe to this fresh data and we see its performance. If it succeeds with the kind of data it has to handle in real life, then it works. Now, why are there 3 sets? To use an analogy from your school days, Think of the training set as examples that you get to work through in class with the teacher, the validation set as the practice problems you'll try on your own at home, and the test set as the questions on your final exam. Practice at home and go back to class as many times as you like, but you only get to take that final exam once. So good luck. So let's test. Here's our final exam. Let's apply our two models and make some predictions. There they are. Notice how they're different. So which one do we trust? Luckily, I've already tasted these wines, and I know what the right answers should have been. Let's see them. There it is, the truth. Now we can use that to score our performance and see how we did. Any mistakes that our models made are going to be highlighted for you in white. The support vector classifier gave us perfect performance, the decision tree, not so much. Before we commit to using one of these, let's make sure we do some statistical inference to check that the 80% accuracy requirement that we set at the very beginning is met. Based on statistical testing, only the support vector classifier passes our minimum performance requirement. It works on new data. That's the one I'll trust. Now that we've looked at the ML process, let me help you avoid making a mess when it's your turn to use it. Most of the failures and gotchas in applied ML aren't about algorithms. They boil down to forgetting the basics of learning and teaching. So always keep in mind two principles that you already know, specifically. Examples should be relevant, and tests should catch memorization. Let's look at principle number 1. If you want to teach me to speak Japanese, giving me a list of Russian words will not help you much. Even if I can form a mental map or recipe that connects Russian with English, I'm not going to do well at the task you wanted me to do. The same idea applies to ML. Your system can only learn the patterns that you show it. If you put garbage in, you get garbage out. ML practitioners, here's a sentence that it's almost worth tattooing on yourself. The world described by your training data is the only world that you can expect to succeed in. If the examples you ask it to learn aren't like the ones you'll get in real life, you'll learn a solution that's great for some other universe. It won't work in this universe, though. And take care to remember that if your business environment changes dramatically, your model won't be relevant unless you retrain it with new relevant data. Principle number 2. If you want to see how well I've learned my Japanese grammar, don't test me on the exact sentences that we practiced together. For all you know, I've just memorized them like a parrot without understanding them. Same goes for ML, so you should always expect performance on your training data to be too good to be true. That's what the term overfitting refers to. The very sound of it, overfitting, fills machine learning practitioners with dread, and rightly so. Overfitting is akin to students memorizing whiteboard examples instead of learning general principles. It could be dangerous to rely on students like that. And there's only one way to catch them doing it. Test them on new examples. That's why it's so important to test your machine learning solutions on relevant, fresh data. Testing is a cornerstone of ML and AI. It keeps you safe and it ensures that what you build works properly and helps your business. Being rigorous and careful when it comes to assessment is the way to ensure that you're using machine learning responsibly. The hardest part of using ML to help your business is not the part involving algorithms. It's deciding what task you want done and thinking about how you'd know if it's being done right. And as long as you're careful to use examples that are relevant for the world you'd like to succeed in, and you're disciplined about checking your solution on fresh data, machine learning is actually pretty easy for you to do. It's okay to try out bad algorithms or ones you don't understand, because if they don't work, you'll catch that when you validate them. When it comes to machine learning, the proof of the pudding is in the eating. If it passes testing, it works. In fact, part of the beauty of machine learning is that you can shift your focus away from the daunting task of trying to understand why a solution works, which was necessary when we had to handcraft our recipes, to carefully ensuring that it does actually work, throwing it away and trying a different algorithm if it doesn't, over and over until you succeed. Everyone is welcome to try it out. You don't need much expertise. So what's the catch? There is one. You need lots of data. In the old days, using large separate data sets for training, validation, and testing was a luxury that few could afford. So machine learning wasn't popular then. Luckily, today's world is generating data like never before. If ML is a rocket engine, data is the fuel. If you have data and the computing power required to crunch it, you don't need a PhD. Come join in the fun. It's an exciting time to be alive. So let's summarize. What is machine learning? It's an approach to making many similar decisions that involves algorithmically finding patterns in your data and using these to create recipes that deal correctly with brand new data. So what's AI then? Let's think about what some classic AI tasks have in common. These are tasks like identifying whether a photo has a cat in it or not, having a conversation, driving a car, or playing games that require intuition. Take a look at this AI learning to play an arcade game. For the first 10 minutes, it plays kind of how I play. Give it 2 hours and it's flawless. And then, after 4 hours, something beautiful happens. This little bundle of math and joy learns strategy. It learns to dig a tunnel. Check out that score. Wow. So what connects these AI tasks? Here's a friendly diagram again. When people do these tasks, we take in complex information through our senses and get the answer as if by magic. You don't even know how you know there's a cat there. You just do. And it doesn't matter how the cat is oriented, you can still tell he's there. Now, it's hard to write a rule that succeeds on every possible cat photo. But you can still find the cat. That's what these tasks have in common. They're all easier for you to actually do than to explain how you did them. If you want to get tasks like these done, programming a computer the traditional way won't work because you can't articulate those instructions. They're too complicated, so we can't expect success using our old approach. AI is the pursuit of success on those tasks, those complex, beautiful tasks that we don't even know how we know the answers for. So in summary, you can think of artificial intelligence as machine learning in pursuit of tasks that are extremely difficult for programmers to handcraft instructions for. Succeeding at AI means unlocking entire classes of tasks that we couldn't possibly solve the traditional way. AI represents a massive leap in human progress. There's so much we can achieve with it. The examples I've shown you are just the beginning. AI is all about complex tasks. And it turns out that if you want your computer to learn complicated instructions, you need more data, more sophisticated algorithms like deep learning, and more computing power. Until fairly recently, no one had the data and the processing power required for success. Because of this, AI used to be in the realm of science fiction. But I'm happy to report to you that the future is here. AI can now perform tasks that we previously thought were impossible. It's already all around you. Just glance down at a smartphone to see some in action. From translation software powered by deep learning, to smart reply for your emails, which helps you write emails faster in your personal style, to automated object detection that helps you organize your photos and retrieve your memories quickly, and oh, so much more. It's easy for you to join in the fun as long as you have the data, the algorithms, and the computing power to pull it all off. And to make sure that you do, Google Cloud has your back. We're putting our vast computing resources at your disposal, along with access to data for classic AI applications, so you don't need to go out there and photograph 1 million cats yourself. And when it comes to algorithms, Google's research teams have designed a powerful suite of tools for you that you can use right out of the box. We've done the math for you, so you don't need to worry about it, letting you dive right into everything from classical machine learning methods to state-of-the-art deep learning. Google Cloud is focused on bringing AI capabilities to market as a rich, broad ecosystem to transform your business. From our pre-trained models to our fully managed TensorFlow, we're providing tools so you can harness the power and beauty of your data. We're making it easy for you to create game-changing applications with AI. So how do you get started? The steps required for AI are the same as for machine learning. Think about your task and define success. Prepare your data in the cloud. Build recipes by trying out algorithms until the results look promising. Test your recipe on lots of new data. And then use your solution to transform your business. As you can see, applying AI isn't about arcane math or magical magic. It's practical, and it's a team sport that brings together a diversity of talents to get a project off the ground. no matter what part of the process you're most skilled at, whether you're a business leader, data scientist, statistician, researcher, programmer, or subject matter expert, there's definitely a place for you to put your best skills to work in creating intelligent solutions. And you don't have to do it alone. We at Google Cloud are here to partner with you to give you the resources and teammates you need to succeed. Today, you're going on a journey with us to discover the best of Google Cloud AI. You'll begin by learning how you can infuse AI into your applications with our machine learning services like Cloud Vision. We have sessions on TensorFlow and Machine Learning Engine to show you how you can build custom models. And lastly, we'll dive into guiding you through the ecosystem of ML accelerators, what's out there, and how to navigate the best hardware choices to power your AI strategy. Thanks for your time.
And welcome back to Cloud on Air. I'm John. I'm here with you from London today. I really hope you enjoyed that session with Cassie. So just as a quick reminder, we're running multiple streams running in parallel. You've just been on the AI stream. The agenda, if you want it for future sessions, is just up on the top left side of your screen. You will see that agenda. We will be running the next sessions shortly. You have the choice, of course, between AI and big data and also industry solutions. So please do have a look at that, see what is attractive to you. You will also notice up there that there are the opportunity to ask questions live. So we have a team of Google engineers in the room next door, excuse me. Sorry about that. We have a team of Google engineers in the room next door answering your questions live. So if you do have questions, please do ask us them, either the sessions you've been to or general questions that you do have. And I'm sorry for the frog in my throat. So just as a sort of a reminder of how we're doing, we started this global on-air session yesterday in the Americas. We went through into Asia Pacific and in London today, hosting you across Europe, Middle East, and Africa. So we hope you're enjoying the session. We have 27 different Google experts coming to you today. So a lot of information if you want it. And that will help you whether you are a beginner in artificial intelligence or whether you're already an advanced user. There is content that will be useful and informative to you. So there's been a few questions that have been coming in. Whilst we have been answering those online live, I will also take some of those questions and actually kind of talk them through with you here. So one of the questions that has come up is Google, of course, being reasonably very well known for its sort of consumer side of things, Google Search, Gmail, things like that. Does Google consumer terms and conditions, do they differ from the business terms and conditions? And the answer is absolutely 100% yes. Very, very, very different terms and conditions. So if you're interested in looking those up, then yes, they are available to you online, but there's a multitude of different things that ensure that your data remains locked down, private, and as ever secure. And there's no scanning or anything like that that goes on with that. You've also been asking about, is your data encrypted at rest? And the answer is yes. I mean, bar sort of very minor number of exceptions, yes, data is automatically encrypted at rest. So if, for example, there were new data coming in, then that data would be encrypted with 256-bit encryption, AES-256. That key itself would then actually be wrapped in another key, so you sort of get double layers of encryption. And you, if you're using these services, do not need to do anything in order to actually make those services get into that encryption. So it's all done for you absolutely automatically. Another question that has come up has been about GDPR. So GDPR, of course, being the European legislation that's coming in May 2018, and a question that broadly says, GDPR, will Google Cloud Services be GDPR compliant? The answer is yes. Google has given a commitment to this. It's already put up the new terms and services. You can go into those if you're already using the Google Cloud Platform, and you can sort of download them, look at them, accept them as you wish. They come into effect in May 2018 when the new legislation comes into effect. You've also asked about where can you find out more information about Google Cloud Security. So absolutely, this is available online. So we do share a lot of information with you. To be fair, we don't share everything because there's still some stuff that we just want to kind of keep under wraps, so there's extra stuff that goes on. But a lot of what we do is laid out in the Google Cloud Security white paper. So this is available to you. You can download it online. It is actually very readable, very understandable, whether you're a security professional or actually whether you're more interested from a business side, but you kind of want to know, is this stuff secure? I would suggest it is incredibly secure. There are very few organizations who can sort of have the level of security expertise that we're privileged to be able to have in this organization. But that is available to you. So if you want that, yes, please do download it. That's the Google Cloud Security white paper. Then a couple of other questions that we have here. One was, how can an organization limit the amount of times, if you like, that their information is going over the wild internet? Well, the broad answer to that is that there is a great deal of benefit that comes from using the Google systems. Because Google itself is a massive global organization, because it connects to most of the major ISPs in the world directly, and because you as an organization are very likely to connect direct to your ISP, then in all likelihood, you will go straight to your ISP. That ISP, in all likelihood, will go straight into Google, so you really will limit that side of things. I'd like at this point to welcome the Industry Solutions track that's just joined us, so welcome back from your session. We're just having a little bit of a discussion of some of the questions that have been coming up. There is, just as a reminder, the opportunity to ask live questions. So just up on your left, the top left of your screen, is the opportunity to ask questions live. Please do keep asking those questions. We've got Google engineers in the room next door, literally answering them online and giving you the information. And we're just taking some of those questions here and talking them through. And just as another reminder, of course, you've got the agenda up on the top left as well. So we're running these 3 tracks for this Cloud OnAir webinar series. We're running 3 tracks. One is for artificial intelligence, one is for big data, and one is for industry solutions. So you'll automatically go back to the session, the track that you were just on previously. If for any reason you want to change track, of course, absolutely doable. Just look on the top right of your screen and you will see there that it will give you the opportunity to change track there. So we're just taking a few questions that were coming in. One was about, do we have any compliance and certifications for Google Cloud? And the answer is yes. Actually, probably too long a list to put in here, but a load of them, yes. Welcome back also to the big data guys. So in just under a minute, we're going to cut through to the next sessions. So just as a reminder, we've got the agenda on the top left of the screen. You can click on there, see which session you would like to take a part in. If you just want to continue in the same track that you were, we've got the artificial intelligence, the big data, and the industry solutions. That will happen for you automatically. If you would like to change track because there's something else that catches your eye, absolutely fine. Just click over here to the top right, and you can go and change track from there. So this is this global on-air event that we have. 92,000 people have chosen to register globally. 28,000 of those have registered across Europe, Middle East, and Africa. So that's us guys. So thank you very much for joining us today. We hope you're finding this very useful, very informative. And we're going to cut over now and go to those next sessions, and I'll speak to you soon. Thank you.